Okay, dear friends, welcome to this new lecture. And in this particular lecture, what we are going to discuss, what are the limitation or drawbacks in Newtonian mechanics. Okay, because soon we are going to Lagrangian formalism, so we should know what are the limitation or the drawbacks in the Newtonian mechanics. Okay, so Newtonian mechanics, you know about Newtonian mechanics. Okay, Newtonian mechanics is basically force vector is equal to mass time of acceleration vector. Okay, so you know this Newton's second law. Okay, drawbacks. So what is happening? Force is a vector quantity, acceleration is a vector quantity, and vectors are very much difficult to deal with. Okay, so we need another principle which is totally independent of the vectors. Okay, so what we will do at later moment, we will go for D'Alembert's principle. Okay, in D'Alembert's principle you will see that it will be a completely a scalar product. And another thing is that if it is f is equal to ma, so it is not only f is equal to ma, f plus small fr is equal to ma. What is small fr? Small fr is nothing but the reaction force. Okay, the reaction force, and you should know that reaction force are very much difficult to deal with, so you have to get rid of this term. So how you can get rid of this term? So that is given by D'Alembert's principle. Okay, so we will discuss it later, but you should know this reaction forces are very much difficult to deal with. Another thing is it is a vector, so force is a vector, acceleration is a vector, and vectors are very much difficult to deal with, so we have to go for a scalar. Okay, so that we will get in D'Alembert's principle and also in Lagrangian formalism. In Lagrangian formalism, what we will get completely, we will get the result in scalar. Okay, so you have to understand this, and the reaction force is very much difficult to deal with. Okay, so these are the drawbacks in Newtonian mechanics. Okay, so you can note it. Okay, so what I am telling, you should note it in your copy. Okay, so I am not writing this, you can just note it what I am telling. Okay, so now what we are going to discuss is very much important and much conceptual. What are the troubles in constant? Troubles. Okay, what are the troubles in constant? Okay, so what happens? Coordinates are no longer independent. Okay, coordinates are no longer independent. What do you mean by it? You know abacus very well, and this is the beats of the abacus. If this is 1, then it is come 10, and then it come 100. You know it. Okay, 100. If these are the beats of the abacus, if I am writing if I am expressing the beats, okay, these are the beats, like this you have the beats of the abacus. What happened? Okay, if these are the beats of the abacus. Okay, if these are the beats of the abacus. Okay, so these beats, okay, these beats are placed in x-axis direction. That means the moment you place the beats in x-axis direction, ultimately y and z becomes 0. So that is a restriction. Y and z are no longer independent. Okay, the moment you feel the beats, okay, in x-axis, automatically y and z will become 0. Okay, automatically y and z will be 0. That means y and z are no longer independent. You cannot take the value as per your choice. Okay, the moment you fix the x, the moment you feel the beats in x, that moment y and z will be 0. So you have to remember this. Okay, so it is very much important. Another thing, you can take a very simple example, and very simple. If I am having a perfect square and the particle is moving to this point, okay, suppose that x square plus y square is equal to 25. So what you think of this equation? If you take x is equal to 3, that means y will be 4. that is compulsory, mandatory. Okay, the moment you fixed x, the moment you take the value of x, y is fixed, so it is no longer independent. You have to take the value of x is equal to 3. The moment y will be fixed, that is 4. Or you can take x is equal to nothing, y is equal to 3, x will be fixed, that is 4. Okay, so here x and y are having two value, either x can be 3 or it can be 4, or y can be 4 or it can be 3. So the values are fixed to satisfy this equation. Okay, that means x and y are no longer independent. You cannot take the value as per your choice. You cannot take x is equal to 5, y is equal to 1, so 25 plus 1, 26. So you cannot take this. Okay, you have to take x is equal to 4, then y is equal to 3, then only you will get 25. That means it is fixed. If x is 4, y is fixed 3. If y is 4, x is free. If y is 4, x is fixed. Understand my point? If x is fixed, if you take the value of y, x is fixed. If you take the value of x, y is fixed. That means both x and y are not independent. Okay, you have to take the value of x is equal to 3. Then that moment you have to take the value of y is equal to 4. The moment you take the value of y is equal to 3, you have to take the value of x is equal to 4. That means these values are fixed. 3, 4, 4, 3, in that combination 3, 4, 4, 3. So these values are fixed. They are no longer independent, like the value that you can take as per your choice. Okay, so coordinates are no longer independent. Another main trouble, you can say the trouble in constant is reaction force. Reaction force of constraint are unknown. Reaction force of constraint are unknown. Okay, so I have you know what is reaction force, like action has a reaction. So if you want to find the reaction force, you should know the action. Okay, otherwise you cannot find the reaction. If I want to know, if I slap you, okay, if I for instantaneous, you think that if I slap you, so how much pain I got in my hand, how can I know this? Okay, if you know the action, how much force you have applied, if you know this, then you can find the reaction. Okay, if you find the action, you will find the reaction. It will be equal and opposite in nature. So reaction forces of constant are unknown. Here reaction force of constant are unknown. For example, you can take the metal. Okay, you can take a metal, and you know that if I consider 1 centimeter cube of copper metal, okay, I am specifically taking copper metal. For that copper metal, what is the electron density? You know that what is the electron density is 10 to the power 22. That means number of electrons which is present is 10 to the 22. So what is happening inside that metal? Electrons are colliding with each other. They are colliding with the iron cores. Okay, so during the course of collision, what happens? One electron is applying force on another electron, that is the action, and as a reaction this electron is getting the same force but in opposite direction. That means if you know the action, you can know the reaction, but it is very much difficult to find the reaction force. So here the reaction force of constant are unknown. So that is the main trouble. Trouble is coordinates are no longer independent. If I have taken the example of abacus beads. Okay, another example was x square plus y square is equal to 25. The moment you take x is equal to 3, you have to fix the value of y. The moment you take y is equal to 3, you have to fix the value of x. Okay, that means x and y can have two values, that is 3 4 or 4 3. Okay, so they are no longer independent. You cannot take any arbitrary values. Okay, so that was the main trouble in the constraint. Okay, you know the constant equation, types of constraint: holonomic, non-holonomic. If time is there, it is reonomous. If there is no time, it is scleronomous. Okay, another main thing that we are going to discuss is configuration space. configuration space. So what we have done, we have taken 3 dimension, okay, and we have taken a system consisting of n number of particles. How much particles? N. N is the total number of particles which is in the system, okay. So if you take the set of the position vector of this, of all these particles, that is for position vector r1t. What is r1t? Position vector of the first particle at certain time t. r2t, position vector of the second particle at certain time t, okay. And this way, if you consider the position vector of nth particle at certain time t, then what happens? This set is known as configuration space. Configuration space. Okay. First of all, you have to understand this n is the number of particle, total number of particles. You have to understand this, okay. Otherwise, it will be very difficult, okay. Total number of particles, okay. So this set is nothing but the configuration space, okay. Configuration space, okay. In next video, we will discuss about the degree of freedom and we will recap the configuration space. Thank you.